Welcome everyone. I am Avani Ghuge from AIIMS Nagpur. I am a third year MBBS student and I am currently in 6th semester. So let us proceed with the session of Ask Me Anything. We shall first cover the basic questions and then level up. Let us see what the first question is. The question 1 is, what is vapor pressure? So if we consider a vessel in which there is a liquid, we know that evaporation occurs even at room temperature. So because of evaporation, there is certain amount of vapor that is present above the surface of liquid, which is present in equilibrium with this liquid. So that vapor exerts a pressure on the surface, which is known as vapor pressure. Let us read the answer. Vapor pressure is the pressure exerted by a vapor in equilibrium with its liquid or solid phase at a given temperature. It depends on temperature of liquid and it increases as the temperature increases. The definition of boiling point also covers vapor pressure in the sense that when vapor pressure reaches the external pressure, which is most of the time atmospheric pressure, then the liquid starts boiling. Let us move on to the second question. What is the difference between EMF, that is electromotive force, and current? Electromotive force is generally provided by a battery. If we look at a battery, if we look at a circuit, we know that current flows from positive direction to the negative. But inside the battery, the flow of charges is from negative to positive. This happens because of the electromotive force. The electromotive force is produced by the chemical reaction that is present in the battery. The major difference is electromotive force drives electrons from negative charge to the positive charge, whereas current is the flow of electrons from positive potential, that is higher potential, to negative potential. Let us read the answer. EMF, it is the energy provided per charge by a source like a battery or generator, which is measured in volts and represents the potential difference that drives the flow of electric charge in the circuit. It is the rate, and current is the rate of flow of electric charge. Current is measured in amperes. It is represented by symbol I and is equals to rate of flow of charge per unit time. And its value depends on EMF and the resistance of the circuit. Let us move on to the question number 3. The question is, what is mutual induction? Now we are familiar with Faraday's law, which states that change in magnetic flux induces current in a coil, right? This is the phenomena of induction of electric current. Now what does mutual induction mean? When a current carrying coil is placed adjacent to a non-current carrying coil, the first coil behaves as a magnet, and this change in magnetic flux induces electric current in the second coil, and this phenomenon is known as mutual induction. Let us read the answer. Mutual induction is the phenomenon in which change in the current in one coil induces a voltage in another nearby coil. This induced voltage produces the electric current. This effect occurs due to the changing magnetic field produced by current in the first coil. There is changing magnetic field in the first coil, which induces an electromotive force, which is nothing but the voltage in second coil. Now let us move on to question number 4. Define friction with examples. Friction is a necessary evil. Nothing is possible without friction. None of our daily activities are present, because if you imagine yourself in frictionless atmosphere or frictionless space, the best example is in zero gravity. It's not possible since there is no relative motion between the surfaces. movement of an object is also not possible. So friction is a force that resists the relative motion between two surfaces in contact. It arises due to irregularities in the surface at microscopic level. So for example, this is a table and you've put a book here. So friction would arise. This is one of the theories why friction is present between the substances. There is microscopic irregularities between the objects which produces microscopic attraction forces which prevents the relative motion between the two surfaces, and this gives rise to friction. Sorry. What are the types of friction? There are two types, static friction and kinetic friction. Now this book is placed on the table. So if you try to move it with minimum force, let us start with 0 Newton, and as you keep increasing 1 Newton, 2 Newton, the book won't move because of the attraction forces present between the table, surface of table and the book, which is known as friction. But after a certain amount of time, this static friction will be overcome and you will be able to move the book. But when you will be able to move the book, kinetic friction will come into place. So static friction is the frictional force that resists the initiation of motion when you're trying to move it with minimal amount of force, say force less than kinetic friction, then at the time the static friction is present. But if you are using force which is more than kinetic friction, then you are able to move the object. There is a graph to depict static and kinetic friction. Static friction increases as the force that you are using to move the object increases. Suppose you are starting with 1 Newton, then you are moving to 2 Newtons and then 3 Newtons. The static friction will also increase accordingly. So the graph of static friction will be like this, straight line, followed by a momentary dip in it, followed by a constant friction force, which is kinetic friction that is present when you are moving the object. Let us move on to question number 5. What does the area under PV graph? The area under PV graph gives the work done, but what does the area under a VP graph represent? In thermodynamics, the formula of work done in a closed system is P delta V, integral P delta V. So if we take this as a PV graph, then the area under this curve will be the work done. But in case of a VP graph, the area under the curve, in case of VP graph, what we are seeing is volume. We are putting it in volume when we are taking it as an independent variable and P is variable. At that time, the area under VP graph, it would represent the change in internal energy during compression or expansion. So in this case, we are considering volume as an independent variable. Let us move on to question number 6. What is the difference between AC and DC current? AC is an alternating current and DC is a direct current. In alternating current, as the name suggests, it is alternating. That is, the direction of current changes with time, and this change of time is periodic. It is typically sinusoidal. So the graph which we would get in case of AC current is like this. It is changing the direction. First it is in one direction and then it will move into the opposite direction. The voltage and current also alternate in direction and magnitude in AC current. Whereas in direct current, the current flows only in one direction and has constant magnitude. It may have constant magnitude. So if we consider this as the axis, then this is the graph of a direct current. I hope this is clear. Let us move on to question number 7. Define the law of conservation of mass with an example. Now I would consider this question as if you want to explain the law of conservation of mass with an example, it would more come into the chemistry domain. But let us read what the law of conservation of mass is. It states that mass cannot be created or destroyed in a chemical reaction. The total mass of a closed system remains constant over time. If you want the implication of this in physics, the best implication is E is equals to mc square. In this equation, we consider mass as a variable of energy. If you consider nuclear disintegration or atomic bombs, when atomic fusion takes place, if atomic fission takes place, at the time, minute amount of mass is lost, which is converted into energy. If we consider this energy as a variable of mass, then the law of conservation of mass can also be stated as then the law of conservation of mass can also be applied there when it comes to physics. But if you want an example, the best area is chemistry. Let us move on to question number 8. What is velocity? Velocity is the rate of change of displacement of an object in a specific direction. Velocity is a vector. Velocity is rate of change of displacement upon time. Displacement is usually represented by s. Velocity is a vector. Let us represent it with the vector sign. Next question. Who discovered electron, proton, and neutron? Another basic question. Electron was discovered by Sir J.J. Thomson in year 1897. The experiment was the cathode ray tube. Proton was discovered by Sir Ernst Rutherford in year 1917. What he did was, he projected alpha particles beam in nitrogen gas, and he had certain detectors which detected hydrogen nucleus. So he hence concluded that all elements were made of hydrogen nucleus. Then neutron was discovered by Sir James Chadwick in the year 1932. Now the discovery is a little bit complicated, so we won't go into the details, just remember the name. Question number 10 is, two mutually perpendicular infinitely long straight conductors carrying uniformly distributed charges lambda 1 and lambda 2 are placed at x equals to 0 along the x-axis and at x equals to a parallel to z-axis. The force between them. Now let us look at this question in according to a diagram. So since they are mutually perpendicular, consider this is a coordinate axis. This is x. This is x-axis. So lambda 1, the straight conductor carrying the charge density lambda 1 is placed at x equals to 0. This is the vector I am representing, just for you to visualize that it is, let us consider it is placed along the x-axis at x equals to 0, and the second conductor is placed at x equals to a. Now they are mutually perpendicular. So if we consider this as z-axis and this is x-axis, then this would be r lambda 2 if this is lambda 1. Now let us calculate the force between them. First we'll consider electric field between the two straight wires, which is equals to 2k lambda by r, where k is the Coulomb's constant, which is 1 by 4 pi epsilon naught. Now let us assume that these both wires lie on the y-axis. They are still perpendicular, but they lie on y-axis. So the distance between them becomes a. Let me redraw it for you. So the diagram will be like this. This is lambda 1, and this right here, which goes into the screen, is the lambda 2, and the distance between them is a. Now this question has been simplified to a greater extent. Now we know the distance between them is a, so we will modify our formula accordingly. E is equals to 2k lambda by a. This is the field exerted by one wire on another. So if we want to calculate the force is directly proportional to electric field. So the electric field here is, I'll draw it on the upper side of the screen. Sorry. Electric field is inversely proportional to, let me clear the screen first. So this electric field is inversely proportional to distance, and since force is directly proportional to electric field, force is also dependent on the distance. So the option is B here. Let us move on to the next question. Question number 11 is, what is projectile motion? What is a projectile? Any object that you have thrown into the air with horizontal component of velocity as well is known as a projectile. Projectile motion is the motion of an object that is thrown near the Earth's surface and moves along a curved path under the influence of gravity. The motion can be broken into horizontal and vertical. If you've thrown a ball vertically, this is a vertical motion. But if you also add a horizontal component to this, horizontal component of velocity, the resultant vector will result into the motion of path into a curved one. So this is a projectile motion. Now this is clear. And since the motion is under the influence of gravity, that is why it's been given in the definition. Question number 12 is, a ball is projected vertically upward from a truck. How does the path appear to different observers? And the question hasn't specified exactly where the observer is when we consider the first part of the question, that is from the ground. So let us assume that the truck is moving like this and we are looking at it from the screen, right? So we are standing here from the ground. A ball has been projected vertically upward. Now, since the truck is moving with a certain velocity, this ball will also have that velocity. So when an observer is looking at that ball from the ground, as per the relative motion of the ball, it will follow the path of a projectile as we have discussed in the previous question. So the path of the ball in this case will be parabolic, just like a projectile. Now, if we are looking at the ball from another truck which is moving at the same speed. Now we too are in this truck which is moving at the same speed. Now the relative velocity between the two trucks is 0. So what will we see is the ball is moving just vertically upwards. So the answer for the second will be in straight line vertically. Straight vertically. Now the truck in which we are there, first let us consider that we are moving faster. So the relative velocity, if we are moving faster, this truck will obviously appear to go slower. That is, the relative velocity, I am writing it as VR, will be in backward direction. So in this case, the projectile of the ball will be like this with VR. So we will see that the ball moves backward relative to observer, that is us. Now if the truck is moving slower, that is, if our truck is moving slower, the relative velocity will be in this direction. So in this case, the projectile that the ball will follow will be this, that is, it will move forward relative to the observer. I hope this question is clear. Let us move on to question number 13. A wooden block of cross-sectional A and height h is released. Let us make the diagram simultaneously. So this is the water container. Let us assume a water container. So we have a wooden block placed here, which has a cross-sectional area A and height h, such that its lower surface touches the water. The block oscillates and then settles into equilibrium. So they are saying that this block will oscillate, and then on reaching equilibrium, this will be the position of the block with its upper surface just on the water. And this is the height h. Okay, this is proceeded from first diagram to the second. Calculate the heat generated. What they're asking is heat generated. So there is no role of SHM in this. Now what is given? They've given that the heat generated during this process is the loss of gravitational potential energy. That is, no energy has been lost anywhere else. So this has simplified our equation. So the heat generated during this process is equals to gravitational potential energy. What is gravitational potential energy? Is nothing but mgh, which is the work done by gravity. But this, we won't be using mgh here as uh, the force, as we have to consider upthrust here. Heat generated let us look at this question. So let us calculate. Work done by gravity will be the change in potential energy of the system. What is change in potential energy? PE1 minus PE2. mgh1 minus mgh2. Since let us assume that the water has the water is abundant, and the submergence of this block will not create any difference in the water level. So the water level will be constant. Only thing we have to consider here is the change in potential energy of this block, which will be nothing but the change in potential energy of its center of mass. This block is also uniform with a uniform surface area. So the center of mass of this block will be at h by 2. So first it was h by 2 above the surface, and now it has been h by 2 below the surface. So total displacement of the block is h. So the change in potential energy will be mg h1 minus h2, which is nothing but mg h, because of the total displacement of center of mass is h. So this is nothing but equal to change in potential energy. Now we have to find out the work done by gravity. Gravity in this case is nothing but upthrust. Gravity is equals to upthrust. Upthrust is V rho g, which is equals to AH rho g. Hence work done by gravity is force of gravity into displacement, which is equals to Ah rho g into h. So this change in potential energy will only be useful when the mass of the object is given, which is not given in this case. So we won't proceed it by this method. We will calculate the work done by gravity by using the upthrust formula. Let me summarize. Work done by gravity is force of gravity into the displacement of the block. Displacement of the block is nothing but displacement of its center of mass, which is h. Force of gravity is nothing but the upthrust applied by the fluid because the block is currently in equilibrium. So the upthrust is V rho g, and hence we have calculated the work done by gravity. Let us move on to next question. Electric current in a circuit is given by I is equals to I naught T by tau, where T is greater than 0 but less than tau. What is the RMS current? The formula for IRMS is equals to under root of 1 by tau integral I T dt. I is given here, I square T dt. I is given here. So let us substitute it in this equation, which is under root of 1 by tau integral I naught T square by tau dt, which is equals to under root of 1 by tau. Limits will be from 0 to tau I naught square T square by tau dt. This expression is constant, so let us bring it outside. 1 by tau square I naught square integral 0 to tau T square dt. Integral T square dt is T cube by 3 under root of 1 by tau square I naught square oh sorry, I did a mistake. Here it will be tau cube, this tau cube into T cube by 3. Let us substitute the limits 0 to tau by tau cube. Answer is I naught by root 3. Let us move on to the next question. A cylindrical wooden log of length L and radius R is floating completely submerged in water. Calculate the force of water pressure on the lower half of cylinder, excluding the atmospheric pressure. Question is that a wooden log is floating, is completely submerged in the water. That is, its upper surface is below the surface of water. So we need to calculate the force of water pressure. Now, pressure exerted on area of a cylinder at a depth d. Pressure at depth h is equals to rho gh. This is the depth h. Let us consider this is the cross-sectional area, which is dA, and this is the small length of the log, which is dh. So the force exerted by water on this area is nothing but P as a component of height dA. That is, force is equals to pressure into area. We know pressure is rho gh, dF equals to rho gh dh. Let us keep this Let us keep this equation two sides. Let us calculate dA. dA is nothing but the surface area of the cylinder that is in contact with water, which is equals to 2 pi r dH, right? Let us substitute it in this equation. So dF is equals to rho gh into 2 pi r dH. The force is integral rho gh into 2 pi r dH. Limits will be from 0 to h by 2. Sorry, length is L now. So the limits will be 0 to L by 2. Force is equals to integral. Let us bring the constant components outside of the integration. Rho g 2 pi r integral h dh with limits 0 to L by 2. So the force is equals to 2 pi r rho g h square by 2 with integral 0 to L by 2. So after solving this, you will get L square by 8. It will be 2 pi r rho g L square by 8. So the force will be equal to pi r rho g L square by 4. Let us move on to the next question. Derive the expression for moment of inertia of a thin uniform circular ring about its diameter. It is better that you know the moment of inertia of a circular ring at its axis, which is equals to mr square. If you already remember the moment of inertia of ring about its diameter, well and fine, which is equals to mr square by 2. Let us first derive moment of inertia of a ring about its axis. So consider the ring with radius r. Let us consider an infinitesimally small portion of this ring of length dx and mass dm. Moment of inertia of this small portion of the ring is equals to dm r square. Now to find out the moment of inertia of the entire ring of mass m, since let us derive the expression of mass in terms of small mass dm. Mass m corresponds to area A of the ring. So the small mass dm corresponds to length, not area A, to the circumference. So now dm is equals to m dx by circumference, which is equals to 2 pi r. Let us substitute this dm in this equation. Di is equals to m dx by 2 pi r into r square is equals to m dx r by 2 pi. Let us integrate to obtain the moment of inertia of the entire ring. Moment of inertia of the entire ring is equals to integral m dx r by 2 pi. M, r and 2 pi are constant. So moment of inertia is nothing but m r by 2 pi integral dx is nothing but x with limits 0 to 2 pi r, since we need to consider the entire ring. So integral dx is nothing but x with limits 0 to 2 pi r. So the answer will eventually be 2 pi r. The moment of inertia of ring about its axis is mr square. By perpendicular axis theorem, the perpendicular axis theorem states that the sum of moment of inertia of two of an object in the same plane is nothing but the moment of inertia of that object along the line perpendicular to it. So, if we consider this as the ring, in order to find the moment of inertia of this ring about its diameter, let us consider this moment of inertia as id. Since diameter is the same, moment of inertia of this ring about a perpendicular diameter will also be id. Agreed? As according to perpendicular axis theorem, id plus id should be equals to moment of inertia of ring about its axis, which is perpendicular, which is passing through this screen. So 2id should be equals to mr square. Moment of inertia of ring about its diameter is nothing but mr square by 2. Okay. Let us move on to the next question. A block is released from height h and must complete a circular motion. So what is the minimum height required? Let us see the basics of circular motion first. If a block is released from height h, for it to complete the entire circular motion, the velocity at this point should be minimum. This should have minimum velocity that should counter the centripetal force that is present in this circular motion. Now we know at different points of circular motion, the centripetal force exerted changes. At this point, the centripetal force will be provided by gravity. Agreed? So we will solve this question with law of conservation of energy. Let us consider the point at which the object is released as A, the point at the bottom as B, and the point at the top where the velocity will be minimum at C. So at point A, there will be the potential energy of the block will be nothing but mg h. We need to find this h such that the energy at this point will be equals to kinetic energy of this object plus the potential energy. Let us consider this potential energy as 0. That will simplify our question. We can also consider the variable of if the object is present at certain height here, we can consider the potential energy of the object here, but eventually it will get cancelled since we are also considering the potential energy of object when it is at top, which will also include the height which it is going to achieve if it is above the ground. So it is better that we neglect that potential energy for the simplicity of our equation. The point B, I just considered it for your understanding, but we are going to consider the initial position and final position for the energy conservation. So our equation should be like this. Potential energy at A should be equals to kinetic energy at C plus potential energy at C. Then and only then the energy will be conserved. We know what the minimum velocity to stay in circular motion is. V min is equals to under root Rg. If you want to derive this, we can also derive it. Since I already stated that the kinetic energy here should be sufficient to combat the centripetal force that is provided by gravity. So at this point, and the centripetal force at this point is nothing but applied by gravity. When the ball is present here at the time, it has a centripetal force which is nothing but gravity. So mv square by r at this point is nothing but mg. R is the radius of this circle, which I'll consider as capital R. So V min should be equals to under root Rg. It is a simple derivation. This is the minimum velocity required for an object to stay in circular motion. Let us come back to our uh, calculation for minimum height that is required. Potential energy at A is nothing but mgh is equals to half m velocity at the point C, which is nothing but V min, minimum velocity, square of which is Rg, plus potential energy at C, potential energy of C from the reference point is mg into height of point C, which is R, plus R is equals to 2R. Let us cancel out mass. Gh equals to Rg by 2 plus 2Rg. H min, minimum height required, is equals to 5R by 2. I hope this is clear. Let me summarize this for you. Potential energy at point A should be equals to, since the object is at rest at point A, so the only energy that it has is potential energy. So the energy at this point should be equal to energy of the block at point C. The energy of block at point C will be potential energy plus the kinetic energy because of the velocity that it possesses. We will substitute the values and then we'll get the answer. Let's move on to the next question. Question number 18. How is the axial tilt of Earth measured, which is 23.5 degrees? Now, this question was actually new for me, so I had to go and search for it. There are 2 to 3 methods to measure the axial tilt of Earth. The most simple one is astronomical method. Astronomical method में what we do is, since this is Earth, consider this is Earth with its axis, and this is the equator. So if you are present anywhere on the surface of Earth, आप यहाँ पे present हो, in that case, the sun is present here. When the Earth is straight, the angle of equator with the sun will be 0. But if the Earth tilts by a certain degree and you are present here, and the angle that sun makes with the Earth, this we are going to calculate. The most simple way is we have already divided the latitudes of Earth at certain degrees. So at a point, if you're present at Tropic of Cancer, Tropic of Capricorn, Tropic of Cancer is present 23.5 degrees north. So अगर आप इस जगह पर present हो and the earth has tilt like this and you are directly below Tropic of Cancer, then the angle that the sun has made with earth, that is used to measure the tilt. So eventually uh, that is how we calculate the axial tilt in by astronomical method. If you're standing below Tropic of Cancer, अगर आप Tropic of Cancer के नीचे खड़े हो, that is the easiest method to calculate. Tropic of Cancer is at 23.5 degrees north latitude and Earth tilt हो चुकी है from its original by certain angle, and sun का angle when sun is directly above head when you're standing at Tropic of Cancer, this means that the Earth has tilted by an angle of 23.5 degrees north. Let us move on to the next question. Two cars are 180 kilometers apart on highway. Car A है, car B है. They are 180 kilometers apart on highway. Let us consider the velocity of car A as v1 and velocity of car B as v2. V2. The first condition is if the cars travel in same direction. If v1 and v2 are in same direction. And the second condition is if they travel towards each other. v1 and v2, they travel towards each other, then they meet in 1 hour. So let us frame the equations. Why? So suppose when they are traveling in same direction, when v2 is also in this direction, and let us divide this page as when they are traveling towards each other, with v1 in this direction and v2 in opposite direction. Now there are two methods. Either I consider the sign of v1 initially as positive और v2 का मैं पहले ही नेगेटिव ले लेती हूँ, और मैं साइंस अभी नहीं यूज करूंगी, and in the end I will get the answer with sign. Sign meaning the direction in which I am going is the positive sign and the direction opposite to that will be negative. So the answer of v2 that we will get, if we get it in negative, that means that it is going in this direction. So I am not going to substitute signs for now. We will get the answer along with sign. As so first question के हिसाब से let us assume that they meet at point C somewhere and displacement is also C, and second they meet somewhere here which is point D and the distance from A is D. So V1 is nothing but distance traveled by A. A ने कितना चला है, A कितना चल रहा है, 180 प्लस C चल रहा है, बाय टाइम कितना लग रहा है उसको B से मिलने में, यहाँ पर 9 hours. एंड V2 B कितना चला है, C डिस्टेंस चला है इन टाइम 9 hours. सो C की वैल्यू क्या आ गई है, V2 9. सो V1 के जगह पे V1 वाली इक्वेशन में लेट अस सब्स्टिट्यूट C की वैल्यू विच इज 180 प्लस 9 V2 बाय 9. 9 को कैंसिल कर देते हैं, V1 इक्वल्स टू 20 प्लस V2. दिस इज आवर फर्स्ट इक्वेशन. ओके, सेकेंड इक्वेशन में इन द सेकेंड केस A ने कितना डिस्टेंस चला है, वेलोसिटी तो कांस्टेंट है, A ने डिस्टेंस चला है D इन टाइम 1 hour एंड B ने कितना चला है, B ने चला है 180 माइनस D इन टाइम 1 hour. सो इसमें लेट अस सब्स्टिट्यूट D की वैल्यू. सो V2 इक्वल्स टू 180 माइनस V1, राइट. अभी लेट अस ऐड इक्वेशन 1 एंड 2. ऐड करें, सब्ट्रैक्ट करें. इक्वेशन 1 को फर्दर लिखते हैं, just so that our calculation becomes easy. NSP2 equals to 20. Let us make this as our first equation. And V1 plus V2 equals to 180 as our second equation. From this we get 2V1 equals to 200. So V1 equals to 100 kilometers per hour. And V2 equals to 180 minus 100 is equals to 80 kilometers per hour. Am I right? So this is our final answer. V1 is 100 kilometers per hour in this direction, and V2 is 80 kilometers per hour. I hope this is clear. We have considered two situations. In first one, we have considered that both cars meet at a point C, and the distance is also C from, if we calculate it from B. In the second case, we have considered a point midway in between A and B, which is D, and the distance is also D from car A. So solving this, these are our first equations. Let us see what our next question is. Should we continue or should we end this session? I think it is almost an hour now, and it is time for us to end the session. Let us meet in the next session.